So we sketch this and we look at your denominator for domain restrictions. The denominator cannot be equal to 0, or we have an undefined function. So let's see what values we cannot use in our domain. We factor this guy. We set them equal to 0. So we say x cannot be negative 5 and x cannot be 3. Negative 5 over here somewhere. Yeah, I'm kind of feeling that. Probably where my asymptote is, right? 3 over here, I kind of see my graph going over it, don't I? So 3 must be what? A point of discontinuity. And negative 5 must be my asymptote. So we say, okay, let's do our domain. From negative infinity to negative 5, then from negative 5 to 3, then from 3 to infinity. I have to take out the points I cannot use. Those are the x values that I cannot use. Your range, save till later. So therefore now, my next step is, I notice this factor on top here is the same as that factor. So let me put my factors and reduce. So now I notice when I reduce this and I'm left with this guy, I know that x minus 3, like Chris said, is a point of discontinuity. I know that x is 3. Even though my graph went over it, I know there's a point there. If you look in your calculator, 3 says error, negative 5 says error, right? So there's two things you cannot use in your denominator. Now, this we call a point of discontinuity. To find the y value, once we reduce this, we plug the 3 into here. So we get 1/8. So y is equal to 1/8. So our point of discontinuity is this, 3, 1/8. Now you can't see that in your calculator because it won't be there, but if you did a calc value on 2.99999, it would be very close to the 1/8 because it's approaching the same number from both sides. We can look at that graphically, remember? We can set your calculator up to look at 3. Since we can't find 3, we can do 3.0001, 2.999, and we can see it approach the 1/8. And whatever that decimal happens to be, you'll see it approach the same decimal. Okay, so therefore, we know that part of it. Now, asymptotes. Let's do our asymptotes. Our vertical asymptotes is from our denominator. They're the factors that are left that I couldn't cancel out. So x plus 5 is equal to 0, and x is equal to negative 5. There's our vertical asymptote. That's what caused your end behaviors to go crazy, right? So if I said, what is the limit of this function as x approaches negative 5, you would say, no limit, right? The limit as x approaches negative 5, there is no limit. They go in opposite directions. If I said, what is the limit as x approaches 3, you would say 1/8, because I can see that my calculator, my graph, my function will converge at the same point. See how we tie your limits into this? Kind of cool, right? That we did this before, but now we just rename this with all the limits. So we have a vertical asymptote. Now, your horizontal asymptote is the same thing that does your infinity limits. I go back to my original and I look at the highest exponent on top in the numerator and the highest in the denominator. And I use my 3 rules. My 3 rules say if the numerator is less than the denominator, then my horizontal asymptote is y equals 0. My limit says as x approaches infinity, it's the same exact rule, but I don't need the y equals. I just need to say 0 because that's the y I'm approaching. And doesn't my graph go off here on both sides as it approaches the 0? See the limits and the horizontal asymptote? So we now have a horizontal asymptote of y equals 0. That's what gives me this. Okay? So now I can do my range. I can't use 0, so I come from negative infinity to 0. From 0 to 1/8, I can't use 1/8. It's not being used anywhere else. So I can't use 1/8 from 0 to 1/8, and then I can use from 1/8 to infinity. Okay? I gotta watch my range. Do your range after you found your point of discontinuity, after you found everything else. What else do we need? We found your point of discontinuities. We found this. We did this guy. My max and my mins, max and mins work this way. But if it's coming across like this, going this way, this doesn't have a min here because this is lower, this is lower, this is lower, all the way out here. These have no max and mins, no relative max and mins. However, we have increasing, decreasing, and we have concavities, if you remember concavities. So I'm going to throw that in here as well. So as we go from left to right, look what's happening to y. It's decreasing. Y is decreasing. Now remember, we do your decreasing values by your x. So we have a decreasing interval. I know it didn't ask for it, but let's put it in there. From negative infinity, your x value, your y is decreasing until x hits the negative 5. Okay? But then it stops. It doesn't go further. But then it starts again at the negative 5, and it decreases until that, God bless you, that open x value right there, till it's at 3. And then it resumes again from 3 to infinity. That's a 3. Sorry. Okay. There's no increasing in this. This would also be your concavity. This is concavity down in this section. This is concavity up in this section. Okay. Remember doing these? This is a good one because we get to tie your limits back into this. Your horizontal asymptotes say y equals, and your limits approach the y values. So we drop the y equal and we say it's equal to 0. Okay? The point of discontinuity we've done before, and we can tell them from both ends. Did you find it?
Yeah.
Okay. All right, we're good with this? See if we can, we're here for a second. And let me help you out. This is a parabola. It has this format. This is what your y squared. Remember, when you set this up, you're only completing the y, the square of the y. Well, let's do this one. I'm only completing this. I need to move these guys to the other side. This is my parabola. My other side, if it's opening up and down, is this setup. And remember the 4P? That helps you find your directrix, your focus. So we complete only the left side. We take half of 6, which is what? 3. There's my complete the square. And what is 3 squared? 9. So now, we've got y plus 3 squared equals negative 8 minus 16. You need that x to have a 1 in front of it. So you factor out, and be careful with your negatives, a negative 8. If it helps you, put it right underneath, right? Negative 8, this becomes x plus 2. There's your format for your parabola. Now the one thing to remember is this is your 4p. So if 4p is equal to negative 8, then p is equal to negative 2. It's a y squared, and it's negative, so which way is it going to open? Left. Good. So we start with your vertex. X is always the H, Y is always the K. Okay, so -2, -3, and it's opening like this. Your focus is inside, your directrix is outside. So if this is your -2, -3, and your P is 2, use your graph to help you rather than your formulas. Come 2 over, so this becomes -4, -3, and go 2 to the right, which becomes 0, so this is your directrix line. Remember the directrix is a line outside of your parabola, the focus is a point inside of your parabola. And the only other thing you really need to find is this point right here. This is an x-intercept when y is equal to 0. The y-intercept we don't have. You can put x equal to 0 and then say that it's not real, but you can put the y in here. Put your y here of 0, probably is easiest. So you're going to get, I'm going to use this one right here. 3 squared is equal to -8x minus 16. So this is your 9. Add 16. I'm just kind of doing it fast. So it's -3 something or other. -3 point something, which makes sense because there's the -2. So it's possible at -3 point something. Or -25/8. Just leave it at that. The y-intercept, we know when we put in the x equals 0, that we won't have one, because we can't take the square root of a negative number. You can just say not real. No real intercept. There's no asymptotes for this one. The asymptotes, if they're applicable, the asymptotes only apply to a hyperbola. I didn't put in directrix, did I? That goes with your focus. Your parabola uses a focus and a directrix. Your hyperbola uses the asymptotes. Good? Do you want to do this one, complete the square? Or are you comfortable? You want to do one more, complete the square? Can I do C? Okay, let's do C. C is going to give you what? A hyperbola. Okay, because we know because these are different. So, the best way to start is to group them. Group your x's together and then your y's together. And move this guy to the other side. When you complete the square, your leading coefficient has to be 1. So we have to factor this out. Then we can complete the square. Now this one, we don't have any other part to complete. So we can leave it like that. So we take half of your -2, which is -1. We square 1. We distribute this out, and we get 4, and that's what goes here. And this is what I was talking about before. Sometimes when you do this and you divide by a negative, you still end up with your hyperbola, but the two pieces just switched around. Because we need this set equal to 1. So we divide everything by -12. If you can watch this, this piece now becomes positive. So I'm going to put this piece first. And reduce 3 divided by 12, you get 4. This one now becomes a negative. And I have nothing to reduce, so that stays. Yes, thank you. I can bring it for you. No, I actually brought it down, but I reduced it. That should be 3, right? Sorry about that. I divided it wrong. Chris said I should have brought my 4 down. I kind of eyeballed it, but I divided it wrong. Better? hang on.
Isn't it 4?
Yes. Let's do this piece over. Because I did it without moving my steps. I should have brought the 4 down, right? And divide by negative 12. So this still stays this. Minus, this is where you cancel out. Thank you. Better? Now, your hyperbola says whoever goes first is the major axis. So your y-axis is the major. So this becomes your a squared, this becomes your b squared. Okay? Instead of like the ellipse where you just make the oval, you make the box. This one has the asymptotes. So what's your vertex, your center on the sky? One, 0. This one doesn't have one, so that's the same as saying y minus 0 squared. So here's where we start the 1, 0. If it helps you, make a translated axis. Your y is the major. That's where your parabolas are going off of. So a, don't forget to take your square roots. A is 2. B is radical 3. And we're going to find c in a minute. That gives you your foci. So up 2, down 2. Over radical 3 is at like 1.7. So it's pushing us a little bit here to here. This is your rectangle that you make. If this was an ellipse, that would be the oval that we use. And we send our asymptotes through here. That's what I use as a guideline to make the little parabolas here. Now, your foci always sit inside your parabolas, so therefore your foci are out here. So that's why when it comes to your c squared, we add a squared plus b squared. Your a squared is 4, your b squared is 3, so your c squared is 7, so therefore radical 7. Now if you can reduce it, reduce it. Radical 7, we can't. So it's along this line. Here's my center, 1, 0. I'm along my y-axis. So this is at the 1, radical 7. This is at the 1, negative radical 7. If you want to write your foci as 1 plus or minus radical 7, that's absolutely fine because there's nothing else to do with that. Okay. And the only other thing we need to do is an asymptote. Your asymptote is this equation of your lines. Don't forget, it runs off your slope. Easiest way is go to your y. Your y is just y squared. It's a line, so it's got to be y equals. If it was y minus 1, we put the y minus 1. But it's just y. And we do plus or minus your slope. Again, you went up 2, you went over radical 3. The change in the y denominator over the change in the x denominator. Slope is y over x. Square root of 4 over square root of 3. As bad as it looks, you can just leave it like that. And then get your x guy. And whatever x says, x minus 1. There's our asymptotes. Good? It's a lot of favorite parts. Okay, if it disturbs you, you can always use their reciprocals, the sign. I'll set it up both ways. So if you're going to solve this, take the square root. When you take the square root of something, you get plus or minus. And because trigs are ratios, make it a ratio. This gives you all 4 quadrants. If you prefer, you can take the reciprocal of this as 1 over 4, because use the reciprocal of cosecant, and then take this. This might catch your eye a little bit better. Don't we know the 1/2 is our special triangles, right? So that might catch your eye if the cosecant doesn't. Where the sine is y over r, your cosecant is r over y. And remember, the R has to be the bigger side. There's your 30 degrees. There's your special triangle. How many times does 30 degrees go into 180? 6. So this side is pi over 6. So then we can set this up 6 pi over 6 and 12 pi over 6. So we've got one angle here, which is pi over 6. One before the 6, which is what? 5 pi over 6. One after the 6, which would be what? 7 pi over 6, good. And one before the 12, which would be 11 pi over 6. If you have trouble with that part, do them in degrees, and if I need them back in radians, just convert them. You can use that function, you can use its reciprocal. When you get to B, this one, remember, looks like this. Factor it. That's a trinomial. So when you factor this one, this factors like this, the 1 and the 1. All you have to do is figure out where your minus and your plus goes. I need this to be the greater one, so my negative has to be here. Once you get this far, and you do this, just don't forget to put the sine word back in there. An angle whose sine is negative 1/2. An angle whose sine is 1. Sine of 1, remember, sine of 1 comes from your quadrants. Quadrantal angles, 1, 0, 0, 1, sine is the y. So it's at the 90 degrees, pi over 2. And your sine of negative 1/2 is in quadrants 3 and 4. It's kind of like these guys. 3 and 4 will be 7 pi over 6 and 11 pi over 6. Same as that one. We had the same, I took the same sign for both of those. Now, this is a quadratic inequality. How do I know that? Because this is going to be quadratic form, and greater than, f less than, inequality, right? Get everything to one side. So first subtract the 12 and get everything to one side. This is key. When that something is greater than or equal to 0, do I want the positives or the negatives? Think your number line. I want the positives. When it's greater than or equal to 0, I want this to be positive. So first thing I have to do is factor this and find my critical values. And yes, the leading coefficient is a 2. If you want, we can factor this using A times C. Why don't we do that? Okay? So A times C. 2 times negative 12. This will help your factoring. Give me factors of negative 24 that add up to 5. 8 and 3. Which one has to be negative? I have to have a positive 5, so the negative 3. And I need this to be positive. I'm just not going to put the plus on. Plot an X right next to it. Now, when you do this, you come down here and you replace your 5x with plus 8x minus 3x. Okay, we're going to do your A times C. Bring this down. It doesn't matter what order you put them in, because they will come out to be the same factors in the long run. Now group. Do the first part first. What can I factor out of the first two terms? 2x. Good. What is left? X plus 4. Now, what can I factor out of the second two that will give me the result of x plus 4? Negative 3. Good. What's my common factor? And then what's my other one? 2x minus 3. Thank you. Good. So I've got an x plus 4 and a 2x minus 3. We set these equal to 0. and x is equal to 3 halves. I added 3 divided by 2. Put these on your number line. Now, to determine if they're opened or closed, we go to your inequality. If there's an equal sign, then we close them. If there's no equal sign, then we keep them open. That gives you your hard brackets versus your soft brackets. Now, you have two choices. You can put this piece in your y equals, and then you can go to your table, pull out a value like such as -5, and look to see is the y value positive or negative. And you can do this for all 3 sections. Or you can remember and just graph this, and in your y equals graph this. These are my zeros, so my parabola is going to look like this, isn't it? It's going to open up. Where are my positives? Where are my y's positive? Up here, up here. My y's are negative down here. So I want, that's why this is important with the 0, I want the positives. I want this one and this one. So I want negative infinity to -4, or 3 halves to infinity. That was a good one because it had your factoring in it, and it had your inequality in it. It's got soft brackets versus hard brackets in it. If we include it, it's a hard bracket. If we don't include it, it's a soft bracket. Granted, it's multiple choice. I can plug these in, but even on your test, I have to see work. I'm really not a multiple choice person, but what I sometimes do is just put the choice out there so that it gives you kind of the hint as to what is my answer supposed to look like. And then you show me work, because if one thing is off, then everything is wrong. Okay?